Welcome to HP Tuners Subaru Training Part 13. In this tutorial, we're going to be taking a look at our open loop calibration method within our mass airflow style tuning. We're going to be relying on a wideband reading coming into our VCM scanner, logging that data, and then learning how we can populate and tune out our wide open throttle area based on the air mass registration coming from our mass airflow. We have a lot to talk about. Let's jump in so we can check this out.
Okay, so let's get started. We're going to be taking a look at working with our MAF calibration process in open loop conditions, comparing a wideband reading to the commanded air fuel or lambda coming from our target air fuel, target lambda table. We can figure out how to create some math channels in our VCM scanner to guide us in updating our mass airflow calibration curve so that we're accurately tracking and representing the airflow at a given MAF voltage. This is a relatively straightforward and seamless process as long as we're setting up everything correctly, which we're going to go through here from start to finish in this tutorial. At the very end, we're going to do a check on our work and make sure that the mass airflow registration in terms of the grams per second airflow coming from our MAF curve is going to be accurately tracked to the horsepower level that the engine's going to be at. There is a direct correlation between the amount of airflow we're ingesting into the engine and the horsepower potential based on that airflow. So we can get a good idea of our work and make sure everything's going to be tracking properly. I actually have the vehicle on a chassis dyno, and we're going to be able to take a look at the screenshot after a dyno pull, after we've done the calibration process here, to do a final check on our work. Again, super straightforward to do this. We just need to make sure we're covering all the details and making sure all of the VCM scanner channels are set up right. Let's go take a look at that real quick in our VCM scanner. So jumping in here to the VCM scanner. Previous tutorial, we were looking at our MAF closed loop error. The closed loop error was taking our short and our long-term field trims and a math channel that I've created. It was adding them together, and it was plotting them in our histogram here that we've created. We were finding we only were able to populate our air here, the percentage of air, how far we were off by, up to about 3.0, 3.13 volt. Anything higher than this, we were transitioning from closed loop to open loop. Open loop is where we ignore the front primary oxygen sensor, and we're strictly going off no feedback from the ECU, so no closed loop feedback, and we're strictly going off what we're measuring for airflow, what we're going in requesting for target air fuel, target lambda, and then converting that from a fuel mass into an injector pulse width. And we should find, if everything is modeled correctly in our air and fuel modeling situation, that we're going to be hitting that target lambda, target air fuel that we're requesting. Now, if we're off, that means that we have something wrong, something misrepresented wrong. So we have our airflow misrepresented incorrectly, or our fuel modeling is misrepresented incorrectly with bad injector data. We can do a check on our work again. We'll talk about that later to determine if what we're modeling in terms of the airflow is accurate. But first, let's talk about the histogram, the setup and layout here of what we're going to be doing. So the first thing, if I jump up here into the MAF EQ ratio air histogram, this is going to look just like our closed loop air, but this is now going to be taking a look at something called EQ ratio air. That's going to be comparing our equivalent ratio commanded to what the wideband is registering. Now, you could have your equivalent ratio commanded in units of air fuel, petrol air fuel, as well as your conversion here. Now, I have my wideband coming in through the MPVI2 cable, through the ProLink cable on my input 1. I have my AEM UAGO gauge coming in through there, and then I've ran a transform function going through here. We can go through this real quick. I've ran a transform function on that voltage at 0 to 5 volt output from the gauge. I have that ran through a transform function that converts the voltage to a lambda with this equivalent ratio scale for the AEM wideband here. We have a couple different choices to choose from for widebands. Now, you could use air fuel ratio, but I like to use lambda. It's just more consistent and more consistency between all kinds of fuel types, because it standardizes looking at the fuel and air mixture based on this universal scale. So 1.0 lambda is stoichiometric between any fuel type, whether that's petrol, methanol, ethanol, diesel, whatever the fuel you're trying to burn. 1.0 lambda is 1.0 lambda. So if we're commanding 0.8 lambda or 1.1 lambda, that is going to be the equivalent across all different fuel types. So it's standardizing our tuning process, just make things more streamlined and straightforward. So in this situation, I want to go in and log equivalent ratio commanded, and in this case, I'm converting using this way to convert my wideband input to my laptop here, so we're logging that as an additional channel. Now, you could go in and actually use the primary sensor. If you didn't have a wideband, which I don't recommend doing this because it's not super accurate, use the actual Lambda Bank 1 that's reading the actual front primary sensor, which is a wideband, but it is starts to get inaccurate at the very rich mixtures. We need a wideband to really determine much past low, mid-11 air fuel. The stock primary sensor isn't super accurate, which is why we want to tag on an actual wideband, which is why I have it set up here as a channel input. But we could use, theoretically, the actual lambda here to be able to get the majority of our calibration done, but I don't recommend that. If you have the opportunity to put a wideband on, you absolutely want to. We always want to be as accurate as possible with our log data, so having a wideband is going to give you that advantage in making sure everything's right. So looking at this, I brought this channel in here and I've converted it into that equivalent ratio using my scaling option here, so it converts the voltage.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.